Let's talk about physics. 1135, page M. I want to talk about a few problems at the beginning of page M, 61 and 63 in particular. I just want to point out on problem 59 that it gives us the length of the pendulum in centimeters. So don't forget, one of those steps in problem solving is we have to convert from centimeters into meters. Okay, so that would be divide by 100, you'd have 1.6 meters. And then don't forget that period is just time. So really that's a quick application of just plugging into this formula right here. You know what pi is, 3.14. You know the length here is 1.6. And then the G value is 9.81. So for 59, just plug in. You have to do the square root. So you have to kind of work backwards, all right? So take the length, divide by gravity, get that number on your calculator and do the square root. And then you can multiply times 2, and then multiply times 3.14. And then our answer can only have, is it going to be 2 or 3 significant figures? Let me look here. You know that in the back of the score key is the solution manual, correct? So not only is there a score key, but there is a solution manual that shows the steps to find the answers. So I'm looking at page 17. They get 2.54 seconds. So I guess we're using 3 significant figures, okay? But I want to, and then 60 is another easy application. They already give it to you in meters, so that one's easy. You're just solving for the period. But let's talk about problem 61 because they want us to find the length in centimeters of the pendulum when we know that the period is 1.8. So let me choose black as my ink color. Here we go. And let's try to set this up here. So we know that the time is 1.8. We're going to leave 2, 3.14, and then we're going to do the square root of L over 9.81. All right, on your calculator, here's what I find students think this is a little bit easier, okay, than the method they use in the PACE. I'm going to divide both sides of the equation by the same thing, which is 6.28. And that's what 2 times 3.14 is. And that way that cancels out. So you're going to get 1.8 divided by 6.28. Let me bring up my calculator here. You do it with me here while I do it on my calculator. Oops. 1.8 divided by 6.28. So I get 0.286624 blah 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 equals the square root of L over 9.81. Now, watch what we're going to do. We're going to take both sides of the equation and square them. So while you have that on your calculator, look for a key that looks like this, x to the second power. On my calculator, I have to do shift square root, but that gives me that squared. So now I have 0.0821534, okay, equals, but now what happened is over here, when you square the square root of something, it just pops out. So I have L over 9.81. So now to solve for L, I'm going to take 9.81 times both sides of the equation, because when I multiply this times 9.81, it'll cancel out. And when I multiply this times 9.81, I'm basically going to have the answer. Yep. All right, let me go back to a pen. Here we go. So 9.81 times that cancels, and then this times 9.81, I get 0.8059. equals the length. Now notice in the problem here, it tells me that I need the answer in centimeters. Find the length in centimeters. So the last step then is to move the decimal twice. And how many significant figures do we have? 2 significant figures. All right. So that looks like I'm going to have 81 centimeters then, because this 5 is going to round that up. Okay. So we could say it's 0.81 meters, but they want the answer in centimeters. So that's how you get the correct answer. All right, moving along to 63. It's a similar problem. They give us the length in meters is 2.5. They give us the time is 4.7. That is in seconds. That's good. But now, unusual, we're solving for the acceleration due to gravity. You said, oh, I thought it was always 9.81, right? But they're assuming that we're doing this on another planet, like Mars, okay? A smaller planet, so it has a smaller acceleration due to gravity. So we're going to figure out what that number is. And so G is the part that we don't know. We can plug in the time, 4.7, 2 times 3.14, and then the square root of L over G, but instead of L, let's go ahead and write the 2.5. All right, so again, we're going to divide both sides by 6.28. I'm going to let you finish this one, because once that cancels and you get this number here, you're going to take that squared. And when you do that to the other side, the 2.5 pops out over G. Okay? Now, how are you going to solve for G? That's tricky. G is on the bottom. Okay, stick with me here. You're going to multiply both sides times G. Okay, so we'll cancel out over here. So you'll have this number times G equals 2.5. Okay, so this number times G equals 2.5. Now to solve for G, you're going to take the 2.5 and divide by this number. So we're going to divide both sides of the equation by the same number, and you'll have G. And then the last step is just to convert into 3 significant figures, because I have, looks like 3 significant figures up here in both of these measurements. All right, the last thing I just want to point out on 64 and 65 is we're solving for the period and frequency here. So frequency is 1 over the period, and so you're just going to take 1 and divide by 0.02. Okay, use your calculator, solve, get your answer. This one says we have a frequency of 100 hertz, and it says what is the period. So remember, the period is 1 over the frequency, or 1 over 100. And again, you're just coming up with a decimal number for that, so divide that and write that answer as a decimal with 2 significant figures. Okay? All right, I think that is the main help that you probably need on page M. Let me just quick point out on problem 66. We're just plugging into the formula that's given, and we just have to remember to use, convert both the radius and the velocity into meters. Okay, so just do that before you solve the problem. And then on 67, again, that's pretty easy. We had already given it to you in newtons and meters, so it's very easy to solve for work. Same thing on number 68. 69 is one of those where we have to actually do 2 steps. They give us a mass, but we are supposed to find work. And work is force times distance. Well, they give us the distance is 5 meters. What is the force? We just have to convert the 50 kilometers or 50 kilograms into newtons. And we do that by multiplying by 9.81. Remember that? And the same thing happens on 70. You add together the people plus the elevator to get a total mass, multiply that times the acceleration due to gravity, and now you have their weight, which is the force. Then you can do force times distance, and you know the work. And a very similar thing happens on number 71. That's just a straightforward problem. All right, so I think that's enough on page M. We'll come back and do a separate video for page N.